Hello, everybody. This is the project review for Team 8 Piano Master. My name is Noah Jackson. I'm an electrical engineer.
You have to hide is that gonna show up this thing at the top?
Oh, yeah, I didn't think about that.
I don't think so. Stop recording.
High floating meeting controls.
Just
Okay, all right. Oh, leave, man. I know, man. Hello, everybody. Oh, gosh, that was bad. Hello, everybody. Oh, my God. I'm so nervy. Oh, man.
Should we just start over?
No, it's fine. That's fine. We can trim it. Hello, everybody. This is the project review for Team 8 Piano Master. My name is Noah Jackson. I'm an electrical engineer.
My name is Nolan Howard. I'm a computer engineer.
My name is Abigail McNair. I'm an electrical engineer.
My name is Ruben Pena. I'm an electrical engineer.
And my name is Davis Winke. I'm a computer engineer.
The objective of our project was to create Piano Master that will automatically provide piano playing training and cost under $300 to design. The user is able to choose between easy, medium, or hard songs based on their level of experience playing a piano. The game will track the user's progress based off of the number of correct notes that they play during the duration of the song. Our motivation was to design a system that applies to the musical knowledge within the group as well as engineering related skills. This is the project implementation. You can see that there's the GUI screen and the keyboard with the LEDs above it. This is the block diagram, and it shows that the Raspberry Pi goes to the PCB and then to the LEDs and also to the keyboard.
The hardware design requirements for this project included a PCB, 3 decoders, 25 shift registers, 203 resistors, and 203 LEDs. As you can see here, this is a snippet of our design for it. So we would go from the Raspberry Pi to the decoders, which would then be used to select specific shift registers, which corresponded to various keys or to specific keys on the keyboard, and would then shift through a series of 8 LEDs to show the user when to click the key. And this is the PCB design software that we used. As you can see on the very top are the decoders, and then below that is the line of the 25 shift registers. Below those is the 203 resistors, which then goes down to the 203 LEDs that are spaced apart to go in front of or on top of the piano. And this is a picture of the back of our LED or our PCB. This is a picture of our implemented PCB. We decided to solder in sockets and plug the chips directly into that to avoid damaging any of the chips. And also the resistors were on this side. And then on the other side, the front, we soldered in all of our LEDs. We used the red LEDs, which would correspond to the white keys on the piano. And the blue LEDs would correspond to the black keys on the piano. And green at the bottom would indicate when to press the key. And for our software design requirements, we wanted to achieve a user-friendly GUI, accurate real-time feedback, and a smooth transition of notes.
For the software design, there are 5 components. First, the startup script is bash script that automatically runs when the Raspberry Pi boots up. It starts the audio synthesizer Fluid Synth, the GUI, and the Scorer program. A display program is run to drive the LED outputs for the song and sends this timing data to the scorer program. The startup script starts Fluid Synth, then it starts the scorer program, and then it connects the MIDI from the keyboard to Fluid Synth and the scorer program using the ALSA driver, and then it starts the GUI. Fluid Synth is a built-in audio synthesizer program on the Raspberry Pi that converts MIDI data from the keyboard to audio output. So the MIDI from the keyboard goes through the Raspberry Pi and then to the speakers. The GUI uses the built-in Python tkinter library. It's designed so the button press would change the display window and call the display program with a specific song file name. And then it will update the score label based on the value in shared memory from the scorer program. The display program reads tempo. The display program starts by reading the tempo from the top of the song file. Then it will continuously read each line of the song file, and it'll read the key numbers from the song file. Then it will update all 25 of the shift registers to shift in the correct LED. And then it'll log this note number and timestamp in shared memory for the score program. Then it will delay a certain amount of time based on the tempo of the song, and it will repeat this throughout the entire song file. The score program is continuously running on the Raspberry Pi. The score program is continuously running on the Raspberry Pi. It waits for a MIDI event, and it uses that MIDI key number and using the correct. The score program is continuously running on the Raspberry Pi. It waits for a MIDI event, and then based on the MIDI key number and the current timestamp, it checks if this timestamp is within the tolerance given by the display program. Then it will update the current score in shared memory for the GUI.
The system provides a user-friendly GUI for song selection. The notes are displayed down the columns of LEDs, and they have a very quick refresh rate so that the human eye can't actually detect the notes are displayed down the columns of LEDs, and they have a very smooth transition. The refresh rate is fast enough to where the human eye can't notice it. Scoring bar shows real-time display of your score as the song progresses. The scoring bar shows real-time display of your score as the song progresses. The GUI I'm going to say here, because I'm probably just going to overlay it with an actual video of the thing.
Wait to record that. You can just skip these slides, right? Yeah. You just go to that first challenge. Or first few challenges.
So I'll basically be overlaying this stuff as I'm saying that. There were a few challenges and bottlenecks when developing our project. One of the first issues we had was receiving MIDI data to the Raspberry Pi while also being able to output the sound through the speaker. No, I'm just thinking about like what to say or. But now we Now the program efficiently runs in unison with our program efficiently runs in unison with the Fluid Synth synthesizer.
Another challenge. Another challenge that we encountered was that 2 pins on the PCB on one of the shift registers was reversed. So the solution was to cut the tracks and solder jumper wires. In the PCB diagram below, you can see on the bottom chip that pin 8 is wired to the pin 1 on the top chip. So what we had to do was to cut that connection and solder the bottom chip, pin 8, to the top chip, pin 8. And then rewire pin 1 on the bottom chip to pin 1 on the top chip. For the future, we could add more complex songs. Oh, wait, I made adjustments to it. I changed it because we deleted one of the. Because I remember I said that we could create new songs.
Yeah, future word.
Yeah.
Did you just change that?
Yeah, I just changed it because we had deleted the potentially increase the size of the keyboard.
Like just while we were doing this video? You
Yeah.
wanted to refresh?
Here, I'll put in that last bullet that you added that's on the poster. Into it real quick and then we can just start.
Okay, so we'll just update as a recording.
But yeah.
Oh, wait,
Yeah, it's not updating.
wait,
Okay.
this is, what's wrong with the 3 that are on there now?
Gio, what are you doing?
I tried to. I deleted. Now it's updated, but on here
Oh.
it hadn't updated. Yeah, it didn't update.
Probably because it was in present mode.
Okay. Is it recording now?
Recording, right.
Your screen share.
Okay.
Oh, shoot.
Still saying, starter.
Somewhere.
Hide meeting controls. For the future, we can add more complex songs and allow users to create and share their own songs or download songs created by others. Another direction is to add a second 25 key system to allow for duets. In conclusion, our final system allows users of any piano skill set to be able to play songs ranging in difficulties from easy to hard. Also, the final score system also provides an accurate score to show how well the user played the song. So references. Do we say anything for the references? Here are our references.
Closing, this is our project 5.
Yeah, ad lib something for us.
This is our project. Project piano team 8. This is our project review for team 8.
This has been Team 8, the Piano Master. Closing sentence.
Bye.
So easy, huh?
This is our project review for team 8 Piano Master. Bye-bye. This is our project review for team 8 Piano Master.
Great work, everybody.
Did you stop the recording?
No. They can snip it.
Download it on